Hello class. Hi, this is Dr. Tithi Banerjee, Assistant Professor of Civil Engineering Department from Swami Vivekananda Institute of Science and Technology. Today I'll be discussing or delivering lecture on basic basic aspects of wave mechanics, which is the major part of coastal hydraulics and sediment transport. And we'll be discussing regarding all the wave mechanics, wave formation, propagation, etc. So let's start the class. So, coastal hydraulics and sediment transport is a very important aspect of civil engineering. Why we will study all those aspects of wave mechanism, coastal structures, coastal erosion, sedimentation. Why we will study that? Because we need to protect our environment as well as coast, right? So, by designing sea walls, griots, breakwater, jetties, these are the all coastal structures. And to build up this coastal structure, the civil engineers play a great role. So, for the build up of these coastal structures like seawalls, griots, breakwaters, jetties, understanding wave action, tides, currents, and sediment movements helps to ensure the structures are stable and durable against any kind of erosion or storm surges. So, to design these coastal structures, seawalls, griots, breakwaters, jetties, study of coastal hydraulics and sediment transport is very essential. Okay. So now another aspect of this subject is it also prevents the coastal erosion and sedimentation. And to have a knowledge of the coastal erosion and sedimentation, we need to develop a vast knowledge of sediment transport, which helps to predict how sand and silt move along the shoreline or away from the shoreline. So the civil engineers, help always plays a great role to control erosion, maintain beaches, and protect coastal property and ecosystems. So, for prevention of the coast, we need to study coastal hydraulics and sediments transport. Okay. So, civil engineer also have a great role to design and maintain of harbors and ports. So, for that maintenance also we need to study sediment transportation, sediment deposition, and the migration of sediments. So these are the important aspects of this subject, coastal hydraulics and sediment transport. Okay, now I will give you bit details regarding the coastal structure. We will study later regarding all those uh, coastal structures. We will study in the next class that what are the coastal structure, type of coastal structures. We will study that. So there are three kinds of coastal structures I have mentioned. One is griots, seawalls, and breakwaters. Right. So seawalls are built parallel to the seawall is a coastal structure is built parallel to the shoreline to prevent shore erosion or sediment erosion, right? So that it cannot help the the habitats of coastal areas and as well as the habitats of aquamarine also, right? So, and what are griots? Griots are the coastal structures which are built perpendicular to the shoreline. Okay, and breakwaters are coastal structures which are built generally in the offshore areas parallel to the coast. So these are the important coastal structures. Okay, so to design these coastal structures, civil engineer had to play a very important role. Okay, and for understanding and for to design all those structures, understanding of wave action, wave mechanics, tidal currents, and sediment movement is very much essential. So in this lecture, we will concentrate on the wave mechanism process, wave generation process, wave propagation process, and other aspects also. Okay, so now we will be concentrating on how wave is generated, right? So wave is generally generated due to the common interplay of moon's gravity, sun's gravity, okay, and the frictional force between the surface of the water and winds. So, so there are the three important forces which are responsible for wave generation of force. Wave generation. One is moon's gravitational force, sun's gravitational force, and the main cause of wave generation is the frictional force between the surface of the water and winds that sweep across it. So, in one sentence, we can deliver that the interplay of this friction and the pull of Earth's gravity result in waves. So now we all know that the ocean is never still. Okay, waves are always propagating and transforming, and swelling are common phenomenon in the ocean. We'll describe all those processes. So whether observing from the beach or from a boat or from a ship, we expect that sea waves will be always active towards the shoreline, right? So the waves are created by energy passing through water, causing it to move in a circular motion. Okay, so the frictional force is generated between the water and the wind, and when the frictional the and the common interplay of the frictional force and moon gravitational force, a centralized circular motion is generated on the wave surface or water surface, right? So however, water doesn't actually travel in waves. Waves transmit energy, not water. Okay, so we need to remember that water doesn't actually travel in waves. So there is no migration of the liquid. So only the waves transmit energy across the ocean, and if not obstructed by anything, they have the potential to travel across an entire ocean basin. And what do we mean by this sentence? That if there is no friction, if there is no if there is no if there is no obstruction of other forces, then the wave have the potential to travel across the entire ocean basin. So wave is constantly generating because of the common interplay of frictional force between water and wind. Okay, so these are the main causes of wave generation, and now we will move towards the next slide. So some important aspects I will describe here, that waves are the most commonly caused by wind. Wind driven waves or surface waves are created by the friction between wind and surface water. As wind blows across the surface of an ocean or a lake, continual disturbance creates a wave crest. So there is a continual disturbance because of the frictional force, and wave crest is generated. We will study in the next lecture that what are the different paths of waves. Okay, so these type of waves are found globally across the open sea and during the coast also. In river also or in pond also we see small waves because of the frictional force, okay, created by wind. Now we need to know some few basic terms. One is shoaling. So what is shoaling? When wave enters shallower water, the speed and wavelength decreases, right? While their wave height increases to conserve energy. Okay, this process causes wave to become steeper. Why? Because when the wave is entering in the shallower water, the intensity of the interplay of wind is greater. That's why the speed increases because of the enormous amount of frictional force. Okay, because the water is in a shallow depth, and because of the enormous intense frictional force, the wavelength increases, sorry, the wavelength decreases and the speed increases, and while the wavelength increases, the wave height increases, right? Sorry, while the wavelength decreases, the wave height increases to con- conserve energy. This process causes, so this phenomenon is known as when the wave height becomes steeper or increases and the wavelength decreases because of the shallowing depth of water. This phenomenon is called shoaling. Okay. Now another important term is refraction. What is refraction? If waves approach the coastline at an angle, the part of the wave in shallower water slows down fast. So while if the wave approaches the coastline at an angle, the part of the wave in shallower water slows down fast. This causes the wave crest to bend and align more parallel to the shoreline. Okay, so refraction is nothing but a process where wave approaches the coastline at an angle, and as a result, the part of the wave in shallower water slows down fast, and this causes wave crest to bend and align more parallel to the shoreline. So this phenomenon is called refraction. Now, what is breaking? Another important term is breaking. What is breaking? As waves continue to shoal and steepen, they eventually become unstable. Okay, if the wave approaches to the coastline in a higher angle, then as a result it eventually become unstable and break. This happens when the wave's orbital velocity exceeds the wave's propagation speed. So when wave is generated, what we have discussed earlier, that when wave is generated, a circular motion is created at the center of the wave. So what is breaking? When the wave's orbital velocity, which depicts that the circular motion created at the center of the wave, is uh, greater than the wave's propagation speed. Okay, in what speed the wave is propagating, we will discuss what is wave propagation. This type of a phenomenon is called breaking, which generally culminates into breakage of waves, right? So coming to the next slide. So if we conclude about the uh, sorry if we conclude why wave generation is occurred, then few important aspects are there. One is the common interplay of wind and water. Stronger winds and longer wind duration produce larger waves naturally. Okay, stronger winds means that the height of the wave will increase and it will produce larger waves. Now there are two small and important terms are there. One is fetch and another is duration. So what is fetch? Fetch is the uninterrupted distance over which the wind blows. So fetch is the uninterrupted distance over which the wind blows. And what is duration? Duration refers to how long the wind blows over a given fetch. Okay, duration refers to how long the wind blows over a given fetch. So these are the important terms related to wave generation, and I have discussed why wave is generating. So wave is generating due to the common interplay of frictional force created by wind and water, and there is moon gravitational force, sun's gravitational force. But the main cause which is responsible for the generation of waves in the coastal area is the frictional force. Okay. Now here is a pictorial diagram where we can see that because of the frictional force, a circular motion is created in the center of the wave and separation of waves by differing rates of travel dispersion. So what does it mean? First, wave is generating due to the frictional force, then wrinkle is formed, and after wrinkle is formed, there we get that imprints of wave we are getting on the water surface, that is known as ripple marks, and ripple marks is generated due to the wind waves, and after that what happens? The crest height increases and swelling is happening. Okay, so these are the important aspects of wave generation. Okay, so first frictional force is generating, then C wrinkles happening, and C wrinkles resulting in formation of imprints of wave action, that is ripple marks. Okay, we can see these imprints in the coastal. We can see these imprints in the soil and sand deposits which are lying in and around coastal areas. So the wave imprints on the soil or on the water is known as ripple marks, which is generally generated by wind waves, and because of the generation of ripple marks, gradually the ripple marks culminates to the formation of swells. Okay, now we will discuss about how wave is propagating. Okay, wave generally begins as a disturbance of some kind, and the energy of that disturbance gets propagated in the form of waves. So we have discussed earlier that water doesn't move, actually the energy transmits from one point to another in a water surface. Okay, so we are most familiar with the kind of waves that break on shore or rock. We can see generally, commonly, we are seeing that in the coastal areas, breakage of waves are a common phenomenon, right? Constantly, the waves are breaking, and this is a very common phenomenon in the coastal areas, right? So, we are most familiar with the kind of waves that break on shore or rock or at the sea surface. But there are many other type of waves that are important to oceanography. So these many kind of waves we will discuss. One is internal waves. So what is internal waves? Internal waves form at the boundaries of water masses of different densities and propagate at depth. So where the internal waves are formed? At the boundaries of water masses. So what does it mean? The boundary of water masses represents actually the common interface surface between the sea and the landmass. Okay, so internal waveform at the boundaries or the common interface surface between sea and landmass, the internal waves are formed. Okay, so the internal waves generally move more slowly than surface waves. Okay, and can be much larger. Because why larger? Why? It is a very interesting question, that why internal waves are much larger. Because internal waves are generating in and around coastal areas. So the waves of the ocean or seas is continuously is being heated by the land mass or the terrestrial area. So constant frictional force are generating in the coastal areas or in the shoreline. So the internal waves are larger, right? Because of the intense frictional force are generating due to the frictional force between landmass and water. Okay, so internal waves form at the boundaries of water masses of different densities. Now what are tidal waves? Tidal waves are due to the movement of the tides. So tides are formed due to the common interplay of the gravitational force of moon and sun. We will discuss in the next class why tidal waves are formed. And tidal waves have a enormous long wavelength. Okay, because why? Because tidal waves. What are the main causes of generating tidal waves? It is moon's gravitational force. Okay, so moon's gravitational force is continuously active on the water surface or ocean surface. So that's why the tides which are generating due to moon gravitational force, sun's gravitational force are also contributing in formation of tide, but the intensity of moon's gravitation force is much higher because moon is more closer to us than sun. Okay, now what is wave propagation, right? So propagation is nothing but transmission of energy that is forming due to a frictional force from one point to another. Okay, so the movement of the wave energy is known as wave propagation. Sorry. Now, we all know that tsunamis are large waves created as a result of earthquakes or other seismic disturbance. Waves are also another kind of waves. Okay, so tsunamis are generally of larger wavelength. Now, what are splash waves? Splash waves are formed when something falls into the ocean and creates a splash. Okay, so because of the sudden splash, a sudden circular motion is generating on the water surface. Okay, so the giant wave in Litua Bay that was described in the introduction to this chapter was a splash wave. Okay, this is an example, that is Litua Bay. Okay, that was described as splash wave. Okay, and what are atmospheric waves? Atmospheric waves form in the sky at the boundary between air masses of different densities. Okay, so what are atmospheric waves? Atmospheric waves form in the sky at the boundary between air masses of different densities. These often create ripple effects in the clouds. So we will not now consider the atmospheric waves, we will only consider it on the ocean waves. Okay, so that I have already discussed that because of the orbital motion, the energy of the wave transmits from one point to another, and this is known as wave mechanics. Now, one important parameters or aspect we need to know that in deep water, longer waves move faster than shorter waves. Longer waves means waves of greater wavelength, and shorter waves means waves of shorter wavelength. So why in the deep water longer waves move faster than shorter waves? Because in deep water the intensity of the frictional force decreases. So that's why there is not more many obstruction in the deep water. So longer waves move faster than shorter waves. In shallow water, wave speed is controlled by depth, right? Why? Because in shallow water, the wave speed generally increases, and deeper the water, the wavelength is sorry, deeper the uh, water, and the decrease of wavelength generally occurs in case of deeper water. Okay. Now this is a pictorial diagram of different parts of waves. Wave crest and trough. The crest is the highest point and the trough is the lowest point of the wave. The vertical distance between them is called the wave height. It is shown in the figure, which is also known as amplitude. Wavelength is the horizontal distance between two crests, which we are seeing in the photo. And when the wave steepens, wave steepness is the ratio of height of the length. Okay, so wave steepness is the ratio of height to length of a wave. When steepness exceeds a certain limit, wave breaks. Okay, breaking waves release energy to the shore, and that's why shoreline and the nearby coastal areas are always in a disturbed conditions. Now there are few terms which I have already discussed, that refraction. What is refraction? As wave approaches shallow water, their speed decreases. That's why the speed decreases, because there are the effect of frictional force is higher in the shallow water, right? That's why the speed decreases. Parts of the wave in shallower water slow more, causing bending. Here we can see that bending of the waves is happening because of the intense frictional force, wave is getting slower and causes bending. So what is shoaling? Shoaling is wave height increases as waves move into shallower depths. Because in shallower depths, breakage of wave is common phenomenon because of the effect of frictional force. So shoaling can lead to higher breaking waves near the shore. Because when the wave height increases, we know that shoaling occurs, and it is very obvious that in the coastal areas, shoaling can lead to higher breaking waves because the height is increasing enormously in case of shoaling. Right. Now these are the references which I have consulted. Okay. Thank you, class. In the next class, we'll discuss in elaboration regarding the wave transformation. As of now, thank you.